Let's simplify radical expressions. So the nth root of x to the nth power equals x if n is odd. And we can see that using what we know about rational exponents. We can rewrite the nth root of x to the n as x to the n to the 1 over nth power. Now that we have a power to a power, we will multiply our exponents. N times 1 over n is 1, so this becomes x to the first power, which is just x. However, we don't know if x is positive or negative because it's a variable. And so when we do take an nth root and the index is even, we do need the radical to simplify to a positive number. So when n is even, it simplifies to the absolute value of x. So for example, let's simplify the square root of 16x to the 8th. So as our first step, we will write each factor as perfect squares. And we're doing squares because here we don't see an index, we've got a square root. That means my index is 2. And we want to write perfect squares because squaring is the inverse operation to square rooting. So I can rewrite 16 as 4 squared, and x to the 8th I can rewrite as x to the 4th squared. Now we will rewrite as one expression squared. So I can rewrite this as the square root of 4x to the 4th quantity squared. And now we'll simplify. And the index n is even, in this case it's 2, so we do need the absolute value bars. So our squaring and our square rooting are inverse operations. We're left with the absolute value of 4x to the 4th. But here, in this case, 4 is always positive, and x to the 4th is always positive. So we don't need the absolute value bars around them. So we can simplify this to just 4x to the 4th. Example 2. Let's take the cube root or third root of m to the 9th n to the 15th. So here we're taking the third root. Remember, these numbers outside the radicals are called indices, or in singular form it's an index. So first, let's rewrite each factor as expressions raised to the third power, since we're taking the third root. So I can rewrite m to the 9th as m cubed cubed, and I can rewrite n to the 15th as n to the 5th cubed. And now we will rewrite as a single expression cubed, or raised to the third power. So we've got the third root of m cubed n to the 5th, all raised to the third power. And now we will simplify. And the index is 3, which is odd, so we don't need absolute value bars. So raising to the third power and cube rooting are inverse operations. So we are left with m cubed n to the 5th. Example 3. Let's simplify the square root of 32x to the 7th y cubed. So first, let's rewrite each factor as products of perfect squares, because we're square rooting, and other factors. So 32, the largest perfect square factor of 32 is 16. So I could write 32 as 16 times 2, or 4 squared times 2. X to the 7th, okay, I can rewrite this as x cubed squared, which gives me x to the 6th. And because I need x to the 7th, I still have an extra x, or an x to the 1, that I need to multiply it by. And then y, for the y cubed, I can rewrite this as y squared, and I still need an extra y, so times y. And now we will rewrite this as a product of expressions raised to the second power, or squared, and something else. So we have the square root of, I'm going to look at the 4, the x cubed, the y. So I've got 4x cubed y, quantity squared, times, and I've got my 2, my x, my y, so times 2xy. So I've got my perfect square as the first expression, the 4x cubed y, quantity squared, and then my something else was the 2xy. And now we will rewrite as a product of two radicals. So I can rewrite this as the square root of 4x cubed y, quantity squared, times the square root of 2xy. And we will simplify the first radical, which is a perfect square. So simplify, our index here is 2, which is even, so we will need absolute value bars. So squaring and square rooting are inverse operations. We're left with the absolute value of 4x cubed y, radical 2xy. Now 4 is always positive, so we don't need that in the absolute value bars, and we could rewrite this as 4 absolute value of x cubed y times the square root of 2xy. Okay, last example, example 4. Here we have the fifth root of 64, x to the 6th, y to the 7th, z to the 8th. So we will rewrite each factor as products of perfect, in this case our index is 5, so fifth powers, and something else. So here we've got the fifth root, so 64. So 2 to the 5th is 32, which is a factor of 64. And I need to multiply this by another 2. So I have 2 to the 5th times 2 is 64. And my x to the 6th I can rewrite as x to the 5th, and I need to multiply that by another x, times x to the 1. And my y to the 7th I can write as y to the 5th. I still need a y squared, so times y squared. And my z to the 8th can be rewritten as z to the 5th power. And if I'm looking at my exponents, I've got 8 minus 5. I still need a z cubed, a z to the 3rd power. So I've got the fifth root of 2 to the 5th times 2 times x to the 5th times x times y to the 5th times y squared times z to the 5th times z cubed. And now we will rewrite as a product of expressions raised to the 5th power and something else. So I've got the fifth root of, let's look at everything that's raised to the 5th power. I've got a 2, an x, a y, and a z. So I've got 2xyz all raised to the 5th power. And then my other factors that are not raised to the 5th power, I've got 2x y squared z cubed, so times 2xy squared z cubed. And now we will rewrite as a product of two radicals. So I've got the fifth root of 2xyz, quantity raised to the 5th power, times the fifth root of 2xy squared z cubed. And now we will simplify. And our index, which is 5, is odd, so we do not need absolute value symbols in this case. So our first radical, we've got raising to the 5th power and taking the fifth root are inverse operations. So we're left with 2xyz, and the second radical will remain the same, so the fifth root of 2xy squared z cubed.